Hello, in this video, let me discuss about Fourier series for continuous function. For that, let me take an example. Expand f of x is equal to x sin x as a Fourier series in an open interval 0 less than x less than 2 pi and deduce this sum of the series is equal to pi minus 2 over 4. First, we have to find the Fourier series for the given function f of x is equal to x sin x, which is defined in the interval 0 less than x less than 2 pi, or you may write this as in an open interval 0 comma 2 pi, both are same. Okay. Now you know the general Fourier series representation of a function f of x is equal to a naught divided by 2 plus sigma n varies from 1 to infinity a n cos n x plus sigma n varies from 1 to infinity b n sin n x. Here a naught, a n and b n are constants. These are calculated by making use of the Euler's formula. A naught is calculated by making use of this formula, that is a naught is equal to 1 over pi integral 0 to 2 pi f of x dx, and a n is equal to 1 over pi integral 0 to 2 pi f of x cos n x dx, and bn is equal to 1 over pi integral 0 to 2 pi f of x sin n x dx. We have already discussed about this problem and we find the Fourier series expansion for this function. I just give the link in the description. For more details, you refer the link. Now I am going to directly take the values. The value of a naught after calculating we have obtained as a naught is equal to minus 2. And the value of a n we have calculated as 2 over n square minus 1. This holds only when n not equal to 1. So if this type of case arises, as I told you already, we go for particular case and calculate the value of a1. The value of a1 as minus 1 by 2 and the value of bn as 0, and also this also holds for the value of n not equal to 1, so that we go for the particular case and calculating the value of b1. So the value of b1 is pi. Now substituting all these values of b1, bn, a1, an and a naught in this f of x, we get the series f of x equal to minus 1 minus 1 by 2 cos x plus twice sigma n varies from here 2 to infinity. Okay, 2 to infinity 1 over n square minus 1 cos n x plus pi sin x. So up to this we have discussed already. The link is given in the description box. For more details, you refer the link. Now we move on to the deduction part. So we have to deduce the sum of this series and we have to show that this is equal to pi minus 2 over 4. For that, I am going to take the point x equal to pi by 2. So if you are going to take out a point, first we have to check whether this point is continuous or discontinuous point. Here the function is defined in interval 0 less than x less than 2 pi. In 0 to 2 pi, pi by 2 is approximately here. So which means that is a continuous point. Already we have discussed about this under the topic of convergence of Fourier series. I am just showing you for your reference. The link is also given in the description box. For more details, you refer the link. So under convergence of Fourier series, if the point which we have taken is a continuous point, what we have to do? We have to substitute the value directly. Okay, this is what we are going to do now, because x equal to pi by 2 is a continuous point. X equal to pi by 2 is which is a continuous point. So if it is a continuous point, then we can calculate the value of f of x at x equal to pi by 2 by just substitute the value directly. Okay, this is what your given function f of x is equal to x sin x. So now we calculate the value of f of x at x equal to pi by 2. Now we have to replace the value of x by pi by 2. So here we have x, so just replace x by pi by 2. You may write either f of pi by 2 or f of x at x equal to pi by 2, both are same. So for your understanding purpose, I have tried like this. Okay. Now minus 1 minus 1 by 2 cos x. Cos x is replaced by pi by 2 plus twice sigma n varies from 2 to infinity 1 over n square minus 1 cos n pi divided by 2 nx. So n pi by 2 plus pi sin x is replaced by pi by 2. You know the value of cos pi by 2 and sin pi by 2. So cos pi by 2 value is 0 whereas sin pi by 2 value is 1. Now here look at here, that is in the left hand side, the function value at x equal to pi by 2. What is f of x? F of x is x sin x. So just replace x by pi by 2, that is pi by 2 sin pi by 2. Since it is a continuous point, so we have to directly substitute the value. So pi by 2 sin pi by 2. Minus 1 minus 1 by 2 cos pi by 2 value is 0 plus twice sigma n varies from 2 to infinity 1 over n square minus 1 cos n pi by 2. So we have to expand this series later plus pi sin pi by 2 value is 1. Now we are going to simplify this. So here itself we have to replace the sin pi by 2 by 1. Okay, as a next step. So since sin pi by 2 is 1, so we get pi by 2, which is equal to minus 1 minus 0. So first term is minus 1, second term is multiplied with 0 means this term vanish. Coming to the third term plus twice sigma n varies from 2 to infinity 1 over n square minus 1 cos n pi by 2 plus pi product 1 is pi itself. So I am going to write these two terms simultaneously here. So plus twice sigma n varies from 2 to infinity 1 over n square minus 1 cos n pi by 2 plus pi. So what we are going to do next here is, so just keep this series along this side, take the remaining terms to other side. So if so, we have pi by 2, if you take this term to the other side, minus become plus, so plus 1. And this pi to other side means plus pi becomes minus pi. That is equal to twice sigma n varies from 2 to infinity 1 over, and just to expand this, that is of the form a square minus b square, isn't it? 1 square or 1, whatever that may be. Shall I write this as a square minus b square is nothing but a plus b product a minus b. So this can be written as n plus 1 product n minus 1 cos n pi by 2. That's all. Now simplifying these two, pi by 2 minus pi. So that is minus half, right? So minus pi by 2 plus 1, which is equal to twice sigma n varies from 2 to infinity 1 over n plus 1 product n minus 1 cos n pi by 2. So what I am going to do here is, you have to take these 2 to this side. So if you take this 2 to other side, so minus 1 by 2 minus pi by 2 plus 1. That is equal to, expand this series by substituting first n is equal to 2 first. If you substitute n is equal to 2, what happens? 1 over 2 plus 1, 3. And 2 minus 1, 1. Am I right? Next, plus, next substitute n is equal to 3. 3 plus 1, 4. 3 minus 1, that is 2. Here you have cos, sorry my mistake, cos 2 pi by 2. Here you have cos 3 pi by 2 plus, substitute n is equal to 4. If you substitute n is equal to 4, 1 over 4 plus 1, 5, product 4 minus 1, 3, cos 4 pi by 2 plus, coming to the next term, substitute n is equal to 5. If Substitute n is equal to 5. 5 plus 1, 6. Product 5 minus 1, 4 cos 5 pi by 2 plus etc. So we have to write up to 4 terms or 5 terms based on our convenience. So what we are going to do next is, we just take this 2 inside. So minus pi by 4 plus 1 by 2, which is equal to, coming to here, 1 over 3 product 1, that is nothing but 1 over, shall I write this as 1 product 3, both are same, isn't it? That is equal to cos 2 pi by 2. Cos 2 pi by 2 is nothing but cos pi. You know the value of cos pi. Value of cos pi is minus 1 plus, coming to the second term, 1 over 4 product 2 cos 3 pi by 2. You know the value of cos 3 pi by 2. What is the value of cos 3 pi by 2? That is cos 270. The value of cos 270 or 3 pi by 2 is, you know already, that is 0. Am I right? So this term becomes 0 since cos 3 pi by 2 is nothing, takes the value 0. So the second term vanish. Plus, coming to the next term, 1 over 5 product 3. Shall I write this as 3 product 5, both are same. So 1 over 3 product 5. So cos 4 pi by 2. Cos 4 pi by 2 is nothing but cos 2 pi. You know the value of cos 2 pi, isn't it? Cos 2 pi. Cos pi is minus 1, cos 2 pi is plus 1. So this takes cos 2 pi value is plus 1. So you have plus 1. Plus, coming to the next, 1 over 6 product 4 cos 5 times pi by 2. That is nothing but cos pi by 2. Cos pi by 2 value is 0. So this term vanish. Plus 6. Plus, coming to the next, suppose if you write the next term, what we get? Substitute n is equal to 6. So if you substitute plus, I am going to write the next term too. Here, if n is equal to 6, what happened? 7 product 6 minus 1, 5 cos 7 times, 6 times pi by 2. If you substitute n is equal to 6, 1 over 7 product 5 cos 6 pi by 2 plus etc. Cos 6 pi by 2 is, what is the value of cos 6 pi by 2? Cos 3 pi. You know the value of cos 3 pi? That is minus 1, isn't it? So in your next term, you have 1 over 5 product 7 minus 1 plus etc. So this type of series we have to get, right? Now, let me take an LCM as 4. If you take an LCM as 4 minus pi by pi plus, here if you take 2 as an LCM, pi plus 2 over 4, which is equal to minus 1 over 1 product 3 plus 1 over 3 product 5 minus 1 over 5 product 7 plus etc. So you take minus outside. So or you can cancel minus on both sides. What you get? Pi plus 2 divided by 4 is equal to, you take minus outside and just take minus outside and we are going to cancel minus on both sides. Okay. So 1 over 1 product 3 minus 1 over 3 product 5 here plus 1 over 5 product 7 minus etc. What happens? These two minus being cancelled. So the sum of the series become reduced as 1 over 1 product 3 minus 1 over 3 product 5 plus 1 over 5 product 7 minus etc. which is equal to, sorry, if you take minus as common outside, you get minus. So pi minus 2 over 4. Isn't it? So up to this, hope you got a clear idea about this topic. Thanks for watching. See you all again.